In the last video, I did an example of solving a pair of linear homogeneous equation, right? And we got two eigenvectors. One was positive and the other was negative. And then we found the solution of the system. Also, we drew the direction field, and we saw that in the line or in the region where the eigenvector is, in that line or in that region, the pointed line are going towards the origin. But on the other side, where the eigenvector is positive, it is going towards going away from the origin. Okay, so let us find out let us do another example where we want to find out the general solution of this pair of differential equations. Okay, and also analyze the solution by using direction field. Okay, the first thing first, what we should do is solution. We want to find out the eigenvalue and eigenvector. Okay, so we have a equals to 5 over 4. This has fraction, little tedious to do, but this is fine. Okay, 3/4, and then 5/4. So what is the characteristic equation? Is characteristic equation is lambda square minus, right, the sum of that. What is 5/4 plus 5/4 is a 10/4, that is 5/2, right? And then lambda, and then plus the determinant. How much the determinant here? 5/4 times 5/4 is 24 over 16, right? And then times, this is the negative multiplication, right? So that will be minus 9/4 will be 16 over so 24 over 16 minus 9 over 16 will be 16 over 16, right? So that will give you 1 equals to 0. You see that? Now what you want to do there is you want to find out the solution there, right? So what are the two factors of this? It is easy to factorize. So if you want to do, this is 5/2, right? So you can write, I think you can write lambda minus 2, and then lambda minus 1/2, see, equals to 0. If you multiply, you will get positive 1, because negative 2 times negative 1/2 is positive 1. Now if you add negative 2 minus 1/2 is negative 5/2, right? Negative 2.5. So that is what the factors are. So lambda equals to 2 and 1/2. Sounds like both of the lambda are positive, right? So next thing we want to do is we want to find out the eigenvector. So for lambda equals to positive 2, the eigenvector will be found by AV equals to lambda V. What is A? A is 5/4, right? And then 3/4, and then 3/4, and then 5/4. Let's say V is XY. You can do X1, X2, no problem, right? But let's say XY, it will be easier. Equals to 2 and then XY. You see that? Now what you want to do is on the left side, you want to do the matrix multiplication. You will get 5 over 4x plus 3 over 4y is equals to 2x, and then similarly 3 over 4x plus 5 over 4y is equals to 2y. You see that? So what you do next is you can multiply. Let me take the first equation or second equation, not a problem. Let me take the first equation. I have to multiply both sides by 4. What do I get? 5x plus 3y equals to 8x, right? Let us subtract 5x. You get 3y equals to 8 minus 5 is 3x, right? So what do you get? You get x equals to y equals to x. So you get 1, 1. So set x equals to 1, you get y equals to 1, right? You will get y equals to 1. So for lambda equals to 2, right? What is the vector V? The eigenvector is 1, 1. Okay, guys. Similarly, lambda equals to 1/2 implies what? You write AV. Similarly, for lambda equals to 1/2, AV equals to lambda V implies 5 over 4, 3 over 4, 3 over 4, and then 5 over 4. And then V, let us say XY, okay, equals to 1/2 and then XY. You see that? Now if you multiply to the left hand side, you will get 5/4 X plus 3/4 Y is equals to 1/2 X, right? Similarly, 3/4 x plus 5/4 y equals to 1/2 y. You see that? Let us take the second equation. I mean, you can pick the first or second equation to solve. So let me multiply by 4 on both sides. You get 3x plus 5y equals to 2y. You see that? So what do you get? If you subtract 5y, you'll get 3x equals to negative 3y. You see that? So x equals to negative y. Now if you set from here, if you set x equals to 1, you will get y equals to negative 1. Thus for lambda equals to 1/2, v, the vector, the eigenvector, will be 1, negative 1. You see that? Now we want to write down the general solution. Okay guys, first of all, let's find out the solution for the first one. So the solutions are, so let's say x1 vector, let's say just write x vector, or you can write x1 vector. X1 vector is, you write e to the lambda t, and then v1, right? Where is v1? This one is v1. You can write lambda 1t, this one is lambda 1, you can suppose, right? And then another is x2 vector equals to e to the lambda 2t times v2, right? So let us write down that this is e to the twice t times 1, 1, right? And another solution is x2 equals to e to the 1/2 t times 1, negative 1. That's what we got. That's the solution, separate solutions, right? Now what we want to do is we want to check the Wronskian. Okay, if the Wronskian is not 0, sounds like it will not be 0, then the general solution you can write. So what is the Wronskian? Wronskian of x1, x2, both are the solutions there, equals to the determinant of e to the twice t, because I'm just distributing this to this and that. And another one is e to the 1/2 t, negative e to the 1/2 t, right? Is this 0? Let's see. E to the twice t times negative e to the negative 1, positive 1/2 t will be e to the twice t minus 1/2 t will be twice t plus 1/2 t, right? So it will be negative e to the 5/2 t, and then minus, because this multiplication will be negative, right? So that's the same thing, e to the 5/2 t. That will be, what is e to the 5/2 t? Minus e to the 5/2 t will be negative 2 e to the 5/2 t, which is non-zero. Hence the general solution is, you can write x vector equals to c1 x1 plus c2 x2, right? This is how you write the solution. That is the linear combination. So what do you write? c1 x1 is e to the twice t times 1, 1, right? And then plus c2 e to the 1/2 t, and then 1, negative 1. This is the final answer. This is the general solution. Okay, since the question also asks you to check the behavior of the solution when t tends to infinity, okay, using the phase portrait, what I'm going to do here is I want to put the right hand side, because what is the right hand side of this? Because we had x prime equals to 5/4, 3/4, and then 3/4, and then 5/4, right? This is what we had. And then we had x, y, right? So if you simplify this, what do you get? This is like x, you can write x prime is like a vector. This is a vector x, right? This is like, you can write x1, x2, or you can write x, y, no problem, right? X prime and then y prime. You can write that way because we wrote x, y there. So this will be 5/4x plus 3/4y, right? This is for the x prime equals to, how about y prime equals to 3/4 x plus 5/4 y. Okay guys, so now I want to enter this right hand side thing one by one. I want to enter this right hand side thing one by one in the app that I have been using. Okay, so what you need to do is go to the system and then enter those equations. So the equations are 5/4x plus 3/4y and 3/4x plus 5/4y. If you do that, this is what you will see. You see that all the pointed lines are going away from every direction. You see that all of them are going away from wherever you wherever you toss, okay, wherever you start, they are going away from the you see that, look at that, they are going away from the origin, right? So that's what you see. So you can say that all the solution curves are going away. So what is happening? Because we got both of the eigenvalues are positive. See, the eigenvalues are positive. So in that case, if both of the eigenvalues are positive, so the pointed lines, the direction field, or the solution curves will go away from the origin. Okay, so look at this example. So the question is the same, but only the numbers here are different. Okay, so we want to find out the general solution, all right, and then we want to find out the behavior of the solution when t tends to infinity. Okay, guys, so first of all, we need to find out, the first thing is we need to find out the eigenvalues. So solution for eigenvalues, the characteristic equation is, the characteristic equation is, you see that lambda square, right, minus the sum of those is negative 4 lambda, right, sum of the diagonal elements, that is a trace, and then plus the determinant is how much, negative 2 times negative 2 is positive 4 minus 1 is 3 equals to 0. You see that? So what do you get? You get lambda square plus 4 lambda plus 3 equals to 0. What are the factors? Lambda plus 3, right, and then lambda plus 1 equals to 0. So you see that the solution are lambda equals to negative 3 and then negative 1. You see that there are two solutions, right, and then we the two eigenvalues, and then those two eigenvalues are lambda equals to negative 1 and negative 3. Let us find out the eigenvector. So for lambda equals to negative 3, what is the eigenvector? It says that for lambda equals to negative 3, you got a v equals to lambda v, implies what is a is negative 2, right? So negative 2, 1, 1, negative 2, right? Let us say v is xy. You can do x1, x2, no problem. Xy equals to lambda is negative 3 and then xy, right? And then what do you get there is you get negative 2x plus y equals to negative 3x. You see that? And similarly x, okay, similarly you get x and then minus 2y, right? X minus 2y equals to negative 3y. Let me pick first or second, whatever. Let's pick the second one, no problem. And then what do you get? If you add 2y on both sides, you will get x equals to negative y, right? So if you take x equals to 1, so you will get, we set x equals to 1. What do you get? Then you get y equals to negative 1, right? You see that? Or you can say y equals to 1, x is negative 1. It's the same thing, okay? So what I'm going to say, hence, what do you get? Hence for lambda equals to negative 3, the eigenvector v is equals to 1, negative 1. Okay, guys. Next for lambda equals to negative 1, what do you get? Av equals to lambda v, negative 2, 1, 1, negative 2, and then xy equals to what? Negative 1 times xy, right? So you get negative 2x plus y equals to negative x. Similarly, x minus 2y equals to negative y, right? So let us pick that one. What do you get? If you add y on both sides, you will get 2y on both sides, you will get x equals to y. So set x equals to 1, what do you get? Y equals to 1. Hence, thus for lambda equals to negative 1, what is the eigenvector? Eigenvector is 1, 1, right? Now, what is the general solution? First of all, let us find out the Wronskian, right? Wronskian x1, x2. By the way, first of all, I want to write down the solution, okay? What are the solutions? You see that for this value, the solution will be x equals to e to the negative 3t, e to the lambda t times vector v, right? 1, negative 1. And for this one, what is the solution? Solution is x equals to e to the negative 1t, means negative t, and then 1, 1. That's what you get, right? So what is the Wronskian? Wronskian is, let's say this is x1 and this one is x2, okay? What do you get? Is x1, x2, the Wronskian of that is equals to determinant of e to the negative 3t negative e to the negative 3t, because you need to distribute that, right? And then another one is e to the negative t and then e to the negative t. If you find out the determinant of that, what do you get? E to the negative 3t times e to the negative t will be e to the negative 4t minus, because this is a negative multiplication, right? Negative e to the 3t times it, that will be plus e to the negative 4t. That is 2 e to the negative 4t, which is not equals to 0. Hence, we got a linearly independent solutions, right? Hence, the general solution is, the general solution is vector x equals to c1 x1 vector plus c2 x2 vector, right? That will be c1 times x1 is e to the negative 3t times 1 negative 1 plus c2, and then x2 is e to the negative t and then 1 1. Okay, this is the final solution of the given system of equation. Now we want to know what happens, what is the behavior of the solution when t tends to infinity, right? What I want to do here is I want to enter that matrix or enter the equation, right? So if you write x, y for the vector x, what do you get? Negative 2x plus y. Okay, so it is negative 2x plus y. And the second one here is 1 minus x minus 2y, right? My x minus 2y. You see that? Look at this. And then if you look at this, from everywhere it is going to the origin. You see that? From everywhere it is going to the origin. So look at that. You see that? From all the points. See? Wherever you pick the initial condition, it is going towards the towards that equilibrium point. Okay? So this is what we found, all right, from the direction field. Okay, guys? So we saw all the three cases. One was when one is negative and other is positive. The other was both positive and the other was both negative. All right?